Hello everyone. Now we're going to see how can we simulate a 4-bit comparator in PSpice. So before we start, I would like to add a new library from here. So far we assume that you guys already have the 7400 library, and also you have the source. We need to add another one. If we go here, this would be source STM. So we need to add this one here. Now let's see how can we simulate the 4-bit comparator. So we're going to start first by adding the comparator. We can add it from this library we have here. So the comparator number is 7485. Double click and let's put it in here. So now we have the comparator here. All right, next, what we're going to see here, this here is 4-bit comparators. So we have basically like two numbers, A and B. A is 4-bit and B is 4-bit also. So A starts from A node A1, A2, A3. B is B node B1, B2, B3. So we're going to compare two numbers. If the numbers, for example, A greater than B, then we're going to have active high here. So this AGTB means A greater than B. So we're going to have active high here at this terminal here, and the other two would be 0. If they are equal, then the middle output would be high and the others would be 0. If B is greater or A is less than B, then this output number 7 here would be high and the rest would be low. All right, so this is how it works, and you can refer always to the lecture notes to see how this comparator works. All right, so what we're going to do here, we're going to assign signal for A naught to A3 and B naught to B3. And what we have here, this one, for example, A less than B, this is A equal B, this A greater than B. Those three terminals, we use them for cascading. If you're going to cascade this with another comparator, let's say, for example, here we can compare 4-bit to 4-bit comparator, but if we want to have, for example, 8-bit comparator, then you need to cascade it with another 4-bit, and you're going to use this here. You can see the configuration and the connection in your lecture notes that is already available online. All right, so now let's start, see how can we do that. First, in order to generate 4 bits, we need something called a bus rather than a wire. So we will be using, of course, wires, which we can get it from here. Also, we were going to use something called bus, and the bus here, we're going to see how can we configure the bus connection and what is the difference between bus and the wire and so on. So I'm going to use here this here, which is say place bus, and I'm going to place my bus here. We need actually like 2 buses because we need 1 bus for A and 1 bus for B. So let's get another one here. And I always like to give myself space when we do this kind of connection. All right, now we're going to see how can we configure it. First, let's see what is the difference between bus and wire. Wire can only handle 1 signal. Let's say, for example, 1 bit at a time. Bus can handle more than 1 bit. Bus can handle 2 bits, 4 bits, 8 bits, and so on. So bus is different than having a wire. So we're going to have the bus here. And the next thing here, we're going to have this bus, let's say for B connections, and this bus for A connections. All right, so now we are going to have two numbers which we will need to uh, compare them. So let's now when you connect from here, of course, this here is just one bit, so you just connect it using a wire to the bus. So let's see how can we do that here. So I'm going to start here with A node. All right, this is the first connection, then A1. Then A2, and A3. All right, we're going to do the same thing for B. So for B, we're going to have B node. We're going to do B node till B3. All right, so now we are done with wiring B and A. And what you have to make sure is there is no connection between, of course, the wires A and B. So here they are not connected. If you see like solid node here, it means they are connected. So just make sure that there is no connection between like different wires we have here. All right, so next we need to assign some values here. As we learn from from the lecture note, if we are not cascading this because we have just to compare 4 bits, then we need to assign certain values here. So the values here would be A equal B in. This would be assigned to level 1 high, and the other two here would be assigned to low value, which is 0. So how would we do that? If you go here to this icon here, which says place power, and I have here high source and low source. So I'm going to select the high source here, and the high source is going to be here. And now I need to have like 2 low sources. So I'm going to get also the low source. Let me just make sure that I selected the right source here for high. So for high is going to be, yes, this one. All right, now let's make the connection. So the connection here will be done using wire. All right, next, what we're going to do, these steps are very important, so let's try to pay attention to this. Next, we're going to label each wire we have here using the net alias, and let's see how can we do that. This here, we're going to label it A node, A1, we said A node, A1, A2, A3, so this would be, we call it 4-bit bus. 4-bit bus, it means can carry up to 4 bits. So let's see how can we do this here. So if you go here and use the net alias here, And I'm going to start here with A0. And I'm going to place it here on this wire. This wire would be A1. So you can do that just automatically by clicking, right? You don't need to name it every time. All right, great. Next, what we are going to do here is we need to name the bus accordingly here from A node to A1. So we know which one is the least significant and which one is the most significant bit. So in order to do that, we're going to click on this here and also click net alias, and we're going to make it a square bracket and then make it 3 to 0. And we can just place it in here. All right, so what we have now, I'm telling now the bus that A node is the least significant bit and A3 is the most significant bit, and this is like 4-bit bus. We're going to repeat the same with B. So let's see how this will look like. All right, next we are going to need here now to put a source for each bus to generate 4-bit signal. So let's see how can we do that. There are multiple ways to do that, but so I wouldn't say which method is better, but I'm just going to show you one method, and it's up to you to choose which method you want. If you go to the new library we have here, which is source STM, and if you go here to this, we call it digital stimulus. We're going to select STM4. It means this here is going to generate 4 bits for us. So let's select one here for A, connected here, and then another one for B. All right, the next important step is to generate this or to see how can we configure these sources. First, let's give this a name here. So we're going to call this, let's call it A4. It means A4 bits. And this one here, let's call it B4, which means B4 bits. Next, let's see how can we configure this. So to configure this here, all what you need to do, just one click on this and right click. And what you need to do here, you are going to go to something called Edit PSpice Stimulus. Click on this, you're going to have another screen here will show up. And from this screen here, you're going to select what kind of signal you need. So this here is going to be bus signal. And the width here is going to be 4. So this is just 4-bit signal. And click OK. All right, now here you will have the chance to configure the signal you need. Before we do that, I would say let's double click on the horizontal axis we have here, and let's change this. I would say let's make it, for example, I would make it, let's say, 10 millisecond. All right, so now we see that the range changed from 0 second to 10 millisecond. And we can set this up manually. All right, so let's see, for example, how can we do that? All right, so one thing I'm going to do here is let's double click on this and display radix. Let's display the numbers here in binary. All right, next what we're going to do, we're going to assign values from 0 to 10 millisecond manually. So in order to do that, if you click on here, on this one here, you will be able to assign this value. So this is the value, let's say, for example, I want, let's say at 1 millisecond from 0 to 1, I'm going to assign 0. And then if you want to change this value, whatever, let's make 2, for example, here. All right, so you're going to see that here we have 2. And then I'm going to show you how can we change even what we have here. So just assign any values you want, 3. All right, so now 2 is here and 3 is here, and so on. So let's make whatever values now, just random values. And this is 3, 1, 1, 0, 0 is 3. And then let's make 5. 6, and so on. 7, and let's make, for example, A is 0101 because H here is hexadecimal. So what we are expressing this here in hexadecimal actually, right? So when we say 1, it's hexadecimal 1. So to binary, for example, it's going to be 100. Now let's say I want to change the value here, whatever value I want, and even I can break it down. I can have more values if I want. If I want to change here a value, I could just double click on it on any square we have here, and we'll be able to set the value. So for example, here the value we have here is 0. If you would like to set it something else, let's make it 1. All right, you will get it 1 as we see here. All right, and so on. So we could easily like control this and generate the signal we see here. All right, so we're going to do something similar for B, and then after we run the simulation, we're going to compare the numbers we have here between A and B and see which signal would be activated at the output depending on the value of A and B. So this is how the comparator works. All right, now let's go back to the other stimulus we have here. So let's make edit a stimulus file. We already have this one is already open, so we need to close this before we can open another. Let's save this, of course. All right, and then we need to right click and just edit PSpice stimulus. Another screen we're going to get here. Of course, here we're going to see the first stimulus, and now we have B4. So let's make it bus, and let's make it also 4-bit. Now we have B4 here. We can do the same thing here. Let's double click here and make it in binary. And of course, the initial value here is 0. So let's say, for example, now I want it 1. So I'm going to make 1 here, and I will click here, and let's say at this point here, I want to transition to 1, and that's what we see now, 0, 1. And then now, of course, we need to compare. So let's make it 2, and let's extend this a little bit. All right, so extend the period here, so we'll be able to compare more numbers. So here we have 2, and then let's just choose any numbers arbitrary, right? So this is up to you. Choose whatever number you want, but this would be in hexadecimal. Let's, for example, make it 9. So now 9 is 1001, as we see here, and let's make it whatever. Let's make it 5. All right, so this is 5 we have here, and let's make it, for example, now I would like to make it 10, but this is hexadecimal, so then 10 would be A. So let's make A here. And now when those two will show up, they are equal. So the, the equal output will be activated. All right, now we are done with setting up our stimulus. So I'm going to save this, just save. And just to close this here, and to close this one too, let's go back to our circuit we have here. Now we need to assign the output here, so, or label the output. So I'm going to have a wire here, and we need another wire here. All right, now let's name this one. So this one, A less than B, or B is greater. So I'm going to just label it B greater, B greater. And this one, they are going to be equal. So let's label it they are equal, for example. And this one, the last one we have here would be A greater. All right, now we are ready to run the simulation file. So all what we need to do, just if you go here, add new file. So let's, whatever name, and create. And then another window will pop up as we see here. So since we already have the excitation signal here till 10 milliseconds, let's make this 10 ms, 10 millisecond, and let's check here. All right, it seems all right. So what you need to do, just okay. Now you are ready to run the simulation. And before we run it, now let's have the voltage marker. So we need voltage marker here. We're going to have one here, one here. Or let's first start with A and then B. So when it shows A first. So A here, and this is B. And then we need one when A is greater, one when they are equal, and one when B is greater. All right, next we just run the simulation, and we're going to see the plots here. All right, it seems we have an error here, so let's try to see what could be wrong here. All right, so let's run it again. When you run it again, another window will pop up, and you should be able to see the waveform. All right, now let's observe the waveform we got here. So what we got here, we got, this is signal A, this is signal B. And what you're going to notice here is when we have 0, 0, now you have 1, the equal here is 1, and the other the other output signals are 0, 0. So A greater is 0, B greater is 0, and equal, it means A equal B. Let's go now here. If you take a look here, this is, of course, the number that shows here, it shows in hexadecimal. So this here is A. A means 10 in decimal, right? A and B is 1. What you're going to notice here, of course, A is greater, 10 is greater than 1. So you're going to find A greater would be 1 high, as we see here, and equal is 0, and B greater is 0. So if you just keep moving here, you could verify. Let's see here, for example, now B here is 9 and A is 4. So B here would be high and the other two signals would be low, as we see here. All right, so we can easily verify. Of course, you could have your own number when you do the stimulus file. So that's all for this tutorial. So hopefully that give you an idea how can you build like 4-bit comparator. If you want to build 8-bit comparator, you need to cascade 2 of these. And also, what will it change here? You need to have here, instead of like 4-bit stimulus, you need to have here 8-bit stimulus. So just select the one that has 8 here, and then you can configure it similar to what we have seen here. All right, thank you all for watching, and please let me know if you have any questions.